In this video, we will examine the solution to a series circuit. In a series circuit, the resistors are tied end to end. For example, here one end of R1 is tied to one end of R2. Also, another characteristic is that there's only one current. Here, I is the only current flowing through the circuit. The other parameters in this circuit is that we have a source voltage of 10 volts. R1 is 2K ohms and R2 is 3K ohms. In order to solve this circuit, our first step is to find the total resistance. The formula for finding the total resistance in a series circuit is to add the resistances together. So R total is equal to R1 plus R2. Substituting in those values, we have R1 is 2K ohms and R2 is 3K ohms. Plugging that into our calculator yields a total resistance of 5K ohms. Step number 2 is to find the total current, which in this case is I. Using Ohm's law, I is equal to V source divided by R total. This is equal to 10 volts divided by 5K ohms. Plugging that into the calculator gives us a total current of 2 milliamps. We can now use that information to find the voltage dropped across each resistor. So step number 3 is VR1 is equal to I times R1. Substituting in our values, we have 2 milliamps times 2K ohms which is equal to 4 volts. We can do the similar type of calculation for the voltage across R2, and we can say VR2 is equal to I times R2. Substituting in our numbers, we have 2 milliamps times 3K ohms Substituting that into the calculator, we get a voltage of 6 volts. We can check this using Kirchhoff's voltage law by saying that V source is equal to VR1 plus VR2. Substituting in what we know and what we've calculated, we have 10 volts is equal to 4 volts plus 6 volts, or 10 volts equals 10 volts. So our circuit checks. That concludes the video on series circuit analysis.